All right, this video is going to go over basically how to draw triangles. I know that sounds stupid, but that's going to be the gist of it. The difference is this time around, they're going to give you some triangles to draw from word problems. Now, this can be rather tricky. The key is draw a nice, pretty picture. So here we go. Station Alpha, I'm on number 1. Coast Guard Station Alpha is 150 miles due south of Beta. So if I was drawing this, I would start with Alpha, Beta, 150. This is the very first thing I would do. Now they're getting an SOS call that's received at each station. The call at Alpha, so here, says it's 55 degrees east. Well, if you think about north, east, south, west, if it's 55 degrees east, it's going to be off over here somewhere. So here's the ship. And I can do better. And what that means is this angle right here has to be 55 degrees. And then the call to Beta says the ship is 60 degrees east. So Beta is hearing it at an angle of 60 degrees. And that is the triangle you could use. So what I would probably do is I would go get this angle and then run a law of sines to answer this problem. I'm not actually going to solve any of these. I don't feel like it. This whole video is just to show you how to draw these triangles. All right, famous Leaning Tower of Pisa was 184 feet high. All right, so there's this tower that's leaning over a little bit that is 184.5 feet high. Okay. At a distance of 123 feet from the base of the tower. So there's some guy standing here measuring angles and whatnot. And he is 123 feet away. So this distance is 123. The angle that he finds is 60 degrees. So this angle right here is 60 degrees. And then they want you to find some other stuff, basically solve the triangle. And they're going to want basically this angle right here. So I would probably run law of sines on that. Okay, moving on. This one's really weirdly worded. Basically, there's a guy and he needs to know the distance between two houses and there's a river in the middle. So the way I started drawing this is I drew the river. Here's the river. And there's going to be a house on one side. We'll call this house A. And then there's going to be a house on the other side. We'll call this house B. And so let's walk through it. He says, standing at house A, he cites 40 degrees between house B and a tree some distance away. So he sees this house B, and then he sees some tree. I'm no artist. This is the tree. And he says that this angle is 40 degrees. So that's the first thing I would do. And one other thing, he tells you the tree is on the same side of the river as house A. So that's why I put the tree there. Then it's 100 feet to the tree is the next thing that they say. So this is 100. And then he's at the tree and he looks at house A and B and he gets an angle of 50 degrees when he looks back at those houses. So that's the triangle I would draw. They want to know the distance between the houses. So they want to know this right here. I would probably run law of sines. Okay, moving right along. There's an airplane that's going from city to A to B that's 150 miles. So we'll call this city A. We'll call this city B. And this distance is 150 miles. Okay, then it says he turns through at an angle of 40 degrees. So what that means is he's going to go through B, turn 40 degrees, and then start going again. So it would be like here, like that. And so like when you're making this triangle, this one's just gonna look something like this. And you'll know this angle right here has to be 140 degrees. And then they also tell you the distance from A to C is 300 miles. So that's the triangle you could use to solve this. Okay, next up, and that one right there, you can use law of sines to solve that. Okay, next up, there's a plane going from A to B, and they actually gave us a triangle here on this one, so we can just use that. I'll just try to write real small. But anyways, they were 10 degrees off course. They were trying to go from here to here, but they were 10 degrees off. So what that means is they were going 10 degrees off. So this angle right here has to be 10 degrees. And they fly 50 miles on that wrong heading. So this right there is going to be 50 miles. And then they say they fixed it once they got to C, and then they flew another 70 miles. So this is 70 miles. And so now you have everything that you need to solve this triangle. It's going to be a law of sines to actually solve the triangle, but then they'll ask you a weird question. If they'll give you the constant speed and they say how much time was lost. So what you need to do is you're going to find this amount. It's like 118 or something. And you do this and this. So 50 plus 70 is the total distance they went, minus this amount, which is the 118 or whatever. And then you divide that by 250 to get the actual amount of time. Again, I don't feel like solving these. I just want to draw these triangles for you. All right, now there's a surveyor crew, and they have this job to do, and it's surveying the height of a mountain. So they measure an angle of elevation to the top of the mountain as 21 degrees, 34 minutes. So I'm just going to start drawing a triangle. And we'll say that they're here. And this angle is 2134. Okay, and if you don't know about degrees, minutes, seconds, basically if they give you minutes, like 34 minutes, you divide that number by 60. So to give you a decimal, like 0.5 something or whatever, 0.57. That's the decimal you use. So that angle is actually like 21.57 degrees. All right, anyways, they see the top of the mountain at this angle. Then they move 500 meters closer. So they come up to, we'll say this point, 507, is this distance. And they measure it again. So now they're looking up like this. And now they see an angle of 3541, 3541. And that right there is enough information for you to solve this, because you'll be able to go get this angle right here, just 180 minus that 35 or whatever. And then once you have that angle, you'll be able to get this angle, and then you can run law of sines to solve this. So that would be the triangle that I use for this. Okay, and then this last one, there's this airplane flying overhead, and there's two people who are 1,000 feet apart. So we'll call this guy person A. We'll call this guy person B, and they are 1,000 feet apart. So this is 1,000. All right, now they say, as the airplane passes over, each guy takes a sighting of the angle to the plane. One guy sees it, so here's the plane. One guy sees it at 40 degrees. The other guy sees it at 35 degrees. And then once you have that information, you have everything you need to know, because you'll be able to go get this angle, and then you can run law of sines. So draw pretty pictures. It helps so much when you when you try to do triangles from word problems, they can get so confusing. Draw a picture. Hope this video helped.